hands-on session. So I'd encourage all of you to type along the commands that are being shown on screen. So before we get started, I'll be showing you how to open a new notebook on Colab. So the link for this has already been put in the chat, so you can click on that. Now, once you open this, this is the interface that you will be met with. So click on new notebook that's here. So this is a new notebook that will open up in front of you. This is known as a code cell. And if you want to add more code cells, you can just click on plus code. If you want to add an additional text cell where you can type in some information about the code, you can do plus text. Now to run a code cell, you can either press this run button or you can press Control Enter or Shift Enter. So I hope that was clear, and that's just a general overview about opening a new Colab notebook and the basic interface of Colab. Okay, now we'll be talking about the data set that we're going to use for today's session, which is the Titanic data set. So this data set was taken from Kaggle. This is actually a competition on Kaggle. And for today's session, we'll be using the train.csv data set. This has already been posted in the chat. I hope everyone's received it. And if you have, please download it. Is there anyone who hasn't gotten that train.csv data set?
Oh, I haven't got it. I don't see it in the chat.
Okay, I'll just resend it.
Yeah, thanks. Even that collab link, I don't see it in the chat.
All right, I'll do that again.
Thank you.
Yeah, no problem. Vignesh, can you try again? I see you've written that you're not able to download the data set. Can you try again? I've sent it again. And so I've sent the train.csv as well as the Colab notebook again. So can you guys check if you can download and make your own book? Like, let me know with a thumbs up or so.
Yeah, you send the link. Yeah, I got it now.
Okay, so once you download the train.csv dataset, you'll have to upload it to the notebook that you're using. So for that, go to the files section. And here there's an option for you to upload a file. So click on that, and we're using train.csv. So you can click on that and upload it. Yes, so now we have train.csv for our session. Okay, now I hope everyone is able to download it and upload it to their notebooks. Okay, I'll be continuing. So we'll talk a little bit about the Titanic dataset. Now this dataset contains information about the passengers who were aboard the Titanic, whose sinking is one of the most infamous shipwrecks in history, as we all know. So this is the train.csv dataset. Now CSV stands for comma separated value. So this is a very common file format that's used in data science. So I'll be explaining this dataset column by column. So we start off with passenger ID, where here we have a unique number that's given to each passenger. It's almost like a serial number. Then we have the column survived. Now survived has two values, 0 or 1. So here 0 indicates that this passenger did not survive and 1 indicates that this passenger survived. Next we have P class. Now P class indicates the ticket class. So that could be either 1, 2 or 3, indicating first class, second class or third class. Then we have the name of the passenger, the sex of the passenger, passenger's age. Then we have this column called SIBSP, which indicates the number of siblings or spouses that this passenger has on board. Then we have P arch, which is the number of parents or children that this passenger has on board. Then we have the ticket, the fare that or the cost, the cabin number, and we have embark. So embark stands for the port of embarkation, which were 3 in case of Titanic. So they are represented by the letters S, C, and Q. So if you actually go to Kaggle and look at the data dictionary, you'll find that these are the 3 ports. So C stands for Cherbourg, Q stands for Queenston, and S stands for Southampton. So that was about the data set. I hope everyone's understood. And have you all been able to open your own Colab notebook? You can like either put a yes in the chat or give a reaction.
Can you please show it again?
What, showing a new how to open a
Open
new
the collab notebook, just that part.
Yeah, okay, sure.
Yeah, thank you.
No problem. So this is that link that I pasted in the chat. So open that.
Okay.
And this is the interface that you'll be met with. So then you click on new notebook.
Okay, yeah.
All right. So that might take some time. And then this is called a code cell. So here is where you'll be typing your code. And you can run it either by pressing this button, or you can either press shift and enter on your keyboard or control enter on your keyboard. And you can add new code cells this way. And you might want to add a text cell to describe your code. So that it can be done using this.
Okay, got it. Thanks.
No problem. And when you have to, once you download train.csv, you'll have to upload it. So when you open file section, you'd be met with this button. So you can click on that and upload your train.csv, which is what we'll be using for this session. Okay, now over to Aditya, who will be talking about data pre-processing.
I hope you guys have done everything so far. So next up, let's look at what are the next commands you need to run. Basically, first thing we import the libraries we want to use for today. So first thing, pandas. Pandas is the library that holds your data. The file you just saw in Excel. Pandas has a data type that can efficiently hold that data and run various operations on the same. So that's pandas. And matplotlib and seaborn are used to run visualizations on the same. They are synchronous with each other, and we'll see towards the end of what kinds of plots or visualizations we'll come up with. Do import all these three. How the syntax goes is import pandas as PD. The library pandas is being imported as a variable PD. You can feel free to use any other variable, but in a general scenario, these are the three variables used for these specific libraries. It's like a standard thing. Um, okay, hope you got that. Once you're done with that, we can get on to reading the file from the drive. So you have uploaded this file here onto the drive, not onto the code or onto Python. So what we need to do to upload it to Python is run read CSV command. So we just learned that this specific file was of the format CSV, which was comma separated values. So pd.read CSV and then the name of the file. The name of the file is given here. Um, in in Colab, it works this way, but in a normal or in case it's present in your drive, you can use absolute or relative links. I guess you have learned about absolute and relative links around the web. So you can give the directories, you can use the dot dot slash. You might have learned about it in Linux too. So that's that. Um, Hope you guys haven't got any error in this part. So to check whether you have read your file properly, you can run the df.head command. So df.head returns you the first 5 data points of your table. So you can have a look at your data, how it looks. Unlike looking at it in an Excel file, this is what normal data scientists do. They just look at the first 5 values and get a taste of how the data looks like. Any problems so far? Okay. I take that as all of you have done it so far. So yeah, one more thing I forgot to mention is df equal to pd.readcsv. Df also is another variable here. It's just a short form for data frame. So data frame is the data type I've been talking about, which pandas uses to hold this data. Data frame is the primary data set which helps pandas store this data and using which you can run various operations. So next we look at df.info. If you run it, you can see that we'll be getting a nice infographic of all the names of our features or attributes. How many non-null values does it hold? And then what are the data types of each of those? You can see that most of these have 890 non-null values. There are a few data points which hold different number of non-null values. And then you can see the data type too. Object is the default data type which pandas uses. Whenever it can't decide, it falls back onto object. So whenever there's an object, we'd prefer to look at it and change it to whatever we like, or we can leave it because it's just a string in most cases. So we can see name and sex, both are just a string. Same goes for ticket. Hope you got that right. Next up, we'll look at tail. We guys reached so far. Anybody an error? Okay. So next we look at df.tail. So once you type that, this is pretty similar to head. So when you type df.head, you saw that we return the first 5 values of your table of your data frame. But in this case, you'll be returned the last 5. Depends what would you like to see, the last values or the first values. You can even put in a number into this as a parameter which should return that many number of data points, which is default to 5. So you see 5 in head and tail. So if you put a number, you'll see that many from the last for tail, from the first on head. That's pretty simple. Next, df.describe. So df.describe whole statistic you get of all the features that are integer and float. All the statistical analysis of those features, which is count, mean, standard deviation, minimum, maximum, and then the 25, 50, and 75 percentiles or quartiles. At that specific quartile, what is the where does my data stand? And then minimum and maximum, pretty simple. Standard deviation, will you have calculated that a lot in your exams? And then mean and count. Count is pretty simple. It's just the summation of all those. It's just the number of those, not summation. How many data points are there? And then mean, calculates the mean. So hope you guys got that came so far. So let's look at the next command we'll be running. Do stop me if you have any errors. We'll love to debug them. Hope there are none so far. Next we look at df.shape. So df.shape just shows you the number of data points versus the number of features or attributes. So we have 891 and 891 data points and 12 attributes. You see that this is not a method because we don't use brackets. That's because the df.shape shape is a kind of data that the data frame holds rather than a method. It doesn't compute the number of data points it holds when we run this. It holds data to show how many are previously present. If you learn about classes, that will be more simple for understand. Next up, we'll look at how many null values you have. So one thing when you're doing data analysis is that you want to get rid of all the null points you have. Null values often tend to spoil your data visualizations as they are inconsistent and are not favorable. So look at how many null values we have. So df dot is null dot sum. So dot is null gives you a proper uh, it just returns the same data frame with true and falses. Dot sum just summates all the values for the specific feature. In case of all being false, you get a 0. And then in case of you having null values, you get the specific number. So in cases where it's like too much, like more than 75%, you are good to delete the specific feature because there's nothing you can do about it. It's just useless. So you end up deleting cabin because you hardly have any data in that specific feature. Whereas embarked and age is also quite up, but well, it's manageable. We'll see how. Hope you didn't get any error because this is a bit more. df dot is null dot sum. Hope you got that. df dot columns. Columns again is a kind of data the data frame holds. So which will return you the name of your columns. So why do you want to look at the name of your columns? It's because you might want to change some column name attribute names because well you might feel they're too long or you might feel they're not appropriate. So how to change it is df.rename and then you provide a parameter columns which is equal to a dictionary that points towards the new name previously holding name pointing to the new name. So another parameter we use here is in place equal to true. So what in place equal to true does is basically it doesn't return a copy of the data set data frame, rather it changes the actual data frame on which we are doing the operation. So when you don't use in place, you can see that you are being returned a new data frame when you run this command. So in most cases, you do that only to check whether what you did actually happened correctly. To actually change the data frame in the actual location, you can put in place equal to true. If you run these both commands, you'll see that passenger ID has changed to PID. So any error come so far? Just take a minute there. Okay, I guess you guys have come so far properly. So yes, let's look at how to drop a whole attribute. So that's often the case that we don't want an attribute to be present either because the information is not helping in our analysis or there's no data in that specific attribute. As we saw in yeah cabin. Cabin had hardly had any values, so we'd like to delete it. Here we'll use the df.drop. So using df.drop, we can delete all the features which we feel are uh, not helping towards data analysis. So passenger ID, cabin, and ticket. So cabin, as we already saw, it has 687 null values, which cannot be filled in any way, any efficient way. And then passenger ID is just the same index, so it does nothing. So I go to remove that. And ticket. The number of the ticket doesn't help in any way. Also, the P class, which is a 1, 2, 3, overshadows the name of the ticket. We are going to delete that too. We see the use of in place again. We use in place here to change the actual data frame. After doing which, if we look at df.columns, we see that those specific attributes have been deleted. So any error in this? Oh yeah. So next up, we look at, we see that embarked has two null values. We'd like to fill that with the mode, the statistical mode. So as equal to that specific attribute dot mode gives the specific mode that s holds as a series. Series s of 0 gives rise gives s is the mode of embarked. So that's what we'd like to fill those specific missing two values with. To fill values, you'll be using fill na df embarked that specific feature dot fill na s of 0. So you'd like to um, you'd want to save this onto a variable s preferably because it's a series and the value is s itself. Df embark dot mode. Just save that into variable and then you put s here at the end. You can see what the variable holds. So s of 0 is the data that we want to fill into the two missing values. To do which we use df that specific feature dot fill in. Do put s0 as a parameter and then obviously in place equal to true. The same goes with age. We have quite a few missing values with age. We'd like to fill age with the mean because that's the best we can do. Or is the mindset of the data scientist who's doing the analysis to think what is most appropriate. In this case, we chose mean. We fill df of age dot mean into df dot age. Fill in it. Now, if we see df dot is null dot sum, we'll see that we don't have any more null values. Any errors, guys? If not, we are going to proceed on to data visualizations. Thank you, guys. Over to Sneha.
Is my screen visible?
Yes, it is.
Okay, okay, cool. So now that we've done basic data pre-processing and data cleaning, our next step would be data visualization. Now, why do we do data visualization? It helps us to understand our data better. Okay, so the first plot for today will be a bar plot, which shows the count of the survivors. So this plot will show how many people survived and how many people did not survive. So we'll start with the basic syntax. We're now giving colors to each of the bars on the plot. So I'm assigning a red color to the people who did not survive and blue color for the people who survived. Now in this variable x, we're doing df survived value counts. So what we're doing here is we're taking df survived. Now survived was a categorical variable. As I mentioned when I was describing the data set, this survived has only two values, either 0 or 1. So 0 indicates that that person did not survive and 1 indicates that the person survived. What value counts will do is it will count the number of people who survived and did not survive. So we're printing that. Then we're going on to plot it. So we're plotting, we're saying kind equal to bar. Now this rot 0 I will explain once I actually show the visualization. And then we're assigning color, the variable color to colors, the list of colors that we gave. Now it's always a good practice to label your x-axis, y-axis and give your plot a title. So I've labeled the x-axis as survivors, the y-axis as counts, and I've given the title of the plot as a bar plot of the count of survivors. Now we have to use this to show the plot. So let's run this cell. So we can see here that the number of people who did not survive, that is 0, is 549. And the number of people who survived are 342. So that's what we obtained by printing the value counts. And this is the bar plot we have. So this is the number of people who did not survive. And this is the number of people who survived. Now, if I were to remove this rod 0, let's see what happens. So over here you can see that 0 and 1 have been turned by 90 degrees. So when you look at it, it doesn't look that neat and appealing, right? When you're presenting a visualization, it's always important to make it look very neat and presentable. So that's how people will understand what you're trying to show them. So now that we've done that back, this is our bar plot that shows the count of the survivors. So did you guys understand this bar plot? Any doubts here? Okay. Now let's do the same exact thing as a pie chart. So again, we're taking x, the variable where we did value counts. And now we're plotting a pie chart. So we're saying here, there we said, what did we say here? We said kind is bar. So here we'll say kind as pie. I'll explain this explode once I actually show the visualization. Now this this command will show the percentage, the percentage of the people who survived and the percentage of people who did not survive on the pie chart itself. So again, we're giving the title here and we're showing the plot. So as you can see, this is 0. So 0, there were 61.6% of the people did not survive, while 38.4% of the people survived. So that's what this does. Now, let's remove this explode and check what happens. So you can see that the pie chart looks together. While with that explode, there was a gap here. So explode is generally used when you want to project out one particular part of the pie chart so that it's more appealing, and you can, when a person looks at it, they catch that. They're like, oh, okay, there were 61.6% of people who did not survive. So that's clearly shown to you when you add just a small bit of explode. So that's what this does. It gives you a gap over here for this visual to be appealing, and it hits you that, okay, there were so many people who did not survive and so many people who survived. So these two charts represent the same thing. It's just two different formats. This was a bar plot and this was a pie chart. Any doubts so far? Okay, then we shall continue.
I have a doubt regarding the names that I've given, like for the bar chart.
Yeah.
You have given 0 and 1. So is there any way we can change that to any string?
So that would include some you can change the column names as attributes here. I'm not showing that here, but you can do that if you want. And for more information about the parameters that are mentioned here, you can go to matplotlib documentation and check it out. So that way you can change the 0 and 1 to survived and not survived, or whatever string you want to change it.
Okay.
Can we move on then? Okay. So now what we're doing is, here we showed a count of the people who survived and did not survive. Oh, also Avinash, this 0 and 1 is printed as it is because that's the data that's been given in the data set. In the data set, it's given as 0 and 1. That's why it's printed that way. Okay. So now we'll do the exact same thing for the gender. So we'll do a bar plot of the count of each gender. We're basically doing the same thing where we're taking the sex column and we're doing value counts. And again, we're doing bar, we're giving an X label, Y label, and we're showing it. So when I run this cell, you can see that there were 577 males aboard the ship and 314 females aboard the ship. And here it's given male and female because in the data set, it's actually written as male and female. That's why it's given this way, as we used value counts. So this is a bar plot that depicts the count of each gender, similar to the count of survivors. Any doubts here? All right. So yeah, and I've also assigned different colors. I gave brown and pink over here. So that was the only difference. Otherwise, it was the same thing. Okay, now let's move on to histogram. So here, let's plot a histogram to check out the frequency of the age of the passengers. So here we're doing plt.hist and we're giving the column that's age. And as per usual, we're giving an X label, Y label, and a title. So this is the histogram that you see. So histogram, from this histogram, what we can gather is that most of the passengers were in the age group of 25 and 30. So that was the very common age group of the passengers who are aboard this ship. So that was just the basic histogram that can be given with this one command. Did any of you have any problems so far with these 4 plots? We did one bar plot for the count of survivors. A pie chart, again, representing the same count of survivors. Then we did the same bar plot for the count of each gender, which was similar to the one of the survivors with just a change in the column name. And then we plot a histogram to understand what the maximum passengers age group were. So that we realized was from somewhere between 25 and 30. So any doubts or any questions? Okay, let's continue. Now we'll be talking about count plot. So count plot is from the Seaborn library. So what we're doing here is, a count plot is basically like a histogram, but for categorical values. So as we discussed before, P class is a categorical value that has 3 classes, 1, 2, and 3. So for each class, we're checking how many people survived. So that's what we're doing here. So we're giving excess P class, and hue or color is based on the people who survived, and we're taking the data from the data frame that we initialized before. We're giving the title and we're showing it. Okay, so as we can see over here, when it comes to ticket class 1 or P class 1, there are close to like 70 people who did not survive. Well, there are over 150 people who survived. Now, when it comes to P class 2, we can see that there are about 100 people who did not survive, and a little less than that, let's say 90 or 80 people who survived. Now, when it comes to class 3, there are over 350 people who did not survive, and close to 100 or 120 people who survived. Now, why do you think that there were so many people who did not survive in the 3rd class? You can like take a guess, think about the Titanic ship as it was, and maybe try to understand.
Maybe priority was given to the first and second.
Okay.
And actually, I think in the design of the Titanic, the third cabin, like the third class cabins, were towards the bottom of the ship. So obviously, when the ship
Yes.
was, yeah, sinking,
Yes, yes.
so
That's the perfect answer. Thank you for that. So I will go back up where I will show you the picture. So yes, so this was where the first class cabins were. This is the second class and this was the third class. So when the ship started submerging, the third class cabins were the ones that were flooded first. So that's why more people were killed there as compared to the cabins on top. So that was a good attempt. Thank you. Okay, so I hope you understood the count plot for this. Now we'll do a similar count plot for gender. So here we look for the number of survivors per class of the cabin. Now we look for the number of survivors per gender. So we're doing the same thing here where we're giving the column and the hue and we're giving a title. Okay, so according to this count plot, we can see with the male gender, there were over 400 people who did not survive, while close to 100 people who survived. And with the female gender, there are like lesser than 100 people who did not survive and about 250 people who survived. Again, why do you think there was this disparity? You can guess, it's okay if you're wrong.
I think while they were evacuating the people, they said ladies and children first.
Yes, exactly, exactly. So when they were calling out for the lifeboats, as soon as the ship started sinking, they first gave preference to women and children. So that's why we see that more people of the female gender survived, while more people of the male gender did not survive. So that was about count plots. Any doubts here or any doubts in any of these plots that we did so far? Okay, so then we'll be moving on. Now we'll talk about outlier detection. What are outliers exactly? So when you're doing data analysis, you'll get certain data points that are belonging to one particular range. So that range might be 100 or 1000 or 10,000, but most of your data points will always belong to that range. Now, if you get one or two data points that are completely on either extremes of that range, then we call those data points as outliers. So outliers are extreme values that completely deviate from observations in the data. So if you take a real life example, assume that you're in a class where the height of the people in that class are around about 5 feet. So it could be lesser, a little less, or a little more. But then there are one or two people in that class who are like 6 foot or 6'1". So those people are considered outliers because they stray far away from the range. They're towards the extreme. So that's why they're considered as outliers. Now, let's take an actual statistical example. So you have these numbers given to you. Assume that these are the observations you got from analyzing some set of data. So when you take the average of these numbers without 60, you get 2.5. And when you take the average of these numbers with 60, you're getting 14. So when it comes to actual analysis, such a huge difference you get. And this huge difference could result in incorrect analysis. So you might lead up in giving a wrong inference or a wrong result because you're taking these outliers into consideration. So it's very important for you to detect and remove outliers. So we use something called a box plot for detecting the outliers. So here I am giving the figure size as 12:7, so it can be the box plot can be seen properly. And again, we're using the Seaborn library where we're giving a box plot. And I'm giving P class and age for now. You can give any of the two columns that are there in the data set. So here, this is how a box plot looks like. So we're giving it for the three classes 1, 2, and 3. And in a box plot, this is known as a box. And the line that's here is known as a whisker. So this is the maximum value. This is the first quartile, the second quartile, the third quartile, and the minimum value. So now any points that lie above the maximum value and below the minimum value, that are these points, as you can see here, diamond shaped, those are called the outliers. So these outliers must not, they will give us incorrect analysis if we actually use them for observations or making other analysis while we're doing it. So any doubts with box plot or outlier detection? Okay, so that brings us to the end of this session. So we just covered certain basic pre-processing techniques and basic data visualization. You can do so much more with this data given. You can plot many other different kinds of plots. And apart from Matplotlib and Seaborn, there are many other libraries that you can use for visualization. So you can use those and plot different kinds of plots using those libraries as well. So any other doubts or queries anyone has? I will be sharing this Colab notebook. Okay, if no one else has any doubts or queries, you can feel free to leave. Thank you so much.